Okay, functions and data analysis fans, our topic for today, this is Unit 2-3, and it's called the Fundamental Counting Principle. And before we start, let me tell you your joke of the day. Why did the Clydesdale give the pony a glass of water? The answer is because he was a little horse. All right, so our goal for today is to understand the fundamental counting principle and to calculate what's called permutations. So as our opening problem here, we have a warm-up problem, example number 1. In getting ready for school, you need to choose a shirt and a pair of pants. You can choose between 4 shirts, so you have red, green, black, and white, and 2 types of pants. You have jeans, you have shorts. How many different ways can you choose 1 shirt and 1 pair of pants? Now, one way to organize this is with what's called a tree diagram. A tree diagram. So we can look at the shirts. I'm going to write them vertically. So we have red, green, black, and white. Okay, so those are the shirts. Then, branching off, if I pick a red shirt, well, there are 2 types of pants that I can pick. I can pick jeans, or I can pick shorts. So I can go red jeans or red shorts. If I pick a green shirt, then I can still go jeans or shorts. If I take a black shirt, I can do black and jeans or black and shorts. And then I can do white and jeans or white and shorts. So for each type of shirt, there are 2 types of pants that I can choose. So this is a total of 1, 2, 3, 4, 5, 6, 7, 8. 8 ways for us to choose 1 shirt and 1 pair of pants. Now, this could get very time-consuming if you have a lot of choices to make. So there's an easier way to think about it. We're making 2 choices. We're choosing a shirt and we're choosing a pair of pants. So ask yourself, how many ways can we pick the shirt? Well, there are 4. We have 4 types of shirts. How many ways can we pick pants? Well, we can pick jeans or shorts, so there are 2 ways to choose the pants. Now, to get the number 8 out of this, what we do is we multiply. 4 times 2 is equal to 8. That is the number of ways of choosing 1 shirt and 1 pair of pants. So what happens is we end up multiplying those numbers together. And what this is called is the fundamental counting principle. Fundamental is something that means really basic but important. It's a foundation for something. And in this case, it's the way that we count when we're choosing the number of ways of doing something. So let's say you have 2 events. It can be picking a shirt is 1 event and picking a pair of pants is a second event. If 1 event can occur in A different ways, so like 4 ways to choose a shirt, and a second event can occur in B different ways, so that would be like 2 ways of picking pants, then together the events can occur in A times B different ways. The way I calculate it is I take the 2 number of ways for each event and I multiply them. We are assuming, though, that the second event is not influenced by the first. In this situation where we're choosing a shirt and pants, we are assuming that jeans or shorts is not dependent on whether I pick a red shirt or a green shirt or a black or a white shirt. So we're assuming that the pants has no effect, or sorry, the type of shirt that we choose has no effect on the type of pants. So we're assuming these are independent events, that the first one does not influence the second one. Okay? If this is real, if this is a real situation, whether you pick pants or jeans might depend on what the color is of the shirt that you're wearing. But we are assuming that it's not. So let's do a couple examples here. You order a pizza. So you can choose between 2 types of crust, 3 types of cheese and 20 different toppings. How many ways can you order a pizza with 1 crust, 1 cheese, and 1 topping? So what I like to do with this, we're going to choose 3 things. We're going to make 3 choices, so I'm going to draw 3 blanks. We're going to choose 1 crust, 1 cheese, and 1 topping. Alright, so the question is, how many different ways can we pick a crust? Well, there are 2 types of crust. So there are 2 ways that we can choose crust. How many ways can we choose a cheese? There are 3 types of cheese. So this is 3. How many toppings are there? There are 20, and we're going to pick one of those. Now the fundamental counting principle says that the number of ways of doing this to pick one of each is to multiply 2 types of crust, 3 types of cheese, and 20 toppings. So 2 times 3 is 6. 6 times 20 equals 120 ways. Now, in a real pizza place, they're probably going to have more choices than that. So there are a lot of different types of pizza that you can create. Number 3, buying a car. There are 2 body styles, 5 colors available, and 3 models. How many ways can you choose the car? Well, we have 3 choices that we're making. We have the body style, we have the color, and we have the model. Now we're assuming that we can only pick one of each. So there are 2 body styles, so those are 2 ways you can choose that. There are 5 colors, so there are 5 ways to pick one color, and there are 3 ways to pick a model. The fundamental counting principle says we multiply these numbers together. 2 times 5 is 10, times 3 equals 30. So there are 30 types of cars that you can choose from this. Number 4, you are taking a 3-question true-false quiz. True-false. How many ways can you answer the questions? Now, if there are 3 questions, that means we have 3 blanks. Each of these is true-false. So each of these has 2 choices. How many ways can I pick an answer to the first question? Well, I can pick true or false, so it's 2 ways. For the second question, 2 ways, true, false. The third one is 2 ways. Now you have to be careful because the answer is not 6. It's not 2 plus 2 plus 2. It's 2 times 2 times 2. In the fundamental counting principle, we are multiplying these values, and so we get 8. So on a true-false quiz, if you randomly guessed, there are 8 different ways that you can answer this. And if you wanted to write them all out, you could. You could say true, 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 false, 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 true, false, false, true, false, true, 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 false, 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 true, false, true, false. Let's see, what am I missing? No. I'm missing one. Oh, false, true, true. Those are your 8 ways of doing it. Obviously, you don't want to have to write all this out, so we do 2 times 2 times 2. And the last problem for this part of the video, for number 5, now you take a quiz with 5 multiple choice questions. So there are 5 questions, 1, 2, 3, 4, 5 blanks. Each question has 4 choices. So this would be like A, B, C, D. You have to pick a choice, all of these. So for each question, you have 4 ways to choose an answer. I could pick A or B or C or D, so that's 4, and then 4. And these are also multiple choice, 4, 4, 4. Now, I have to multiply these, and if we do that, so 4 times 4 times 4 times 4 times 4 equals 1,024 ways. The other way to do this is you could do 4 raised to the 5th power. That exponent means I'm going to take my base, the 4, and multiply it 5 times. Okay? And notice that's also 1,024. So if this is multiple choice, there are 1,024 ways to answer the quiz. There's no way that we want to write all that stuff out. Okay? So this is why this is an easier way to do this. So 4 raised to the 5th equals 1,024. And that is the end of part 1.